Hi guys, welcome. Today we're diving into the world of process economics, a critical discipline that shapes how industries balance costs, value, and innovation. Whether you're an engineer, technologist, manager, or student, understanding these principles will empower you to make smarter decisions in any industrial setting. Let's begin. As a student taking the course of process plant design, you need to understand the basics of process economics. South. What exactly is process economics? Think of it as the science of balance. It's about answering three key questions. How much will this process cost? What's the return on investment? And how do we minimize waste? Imagine you're designing a new production line. You could choose the cheapest materials, but what if they wear out quickly, leading to higher maintenance costs? Or you might invest in expensive automation upfront to slash labor expenses over time. Process economics acts like a GPS for industrial operations, guiding teams to the optimal path where costs and value intersect. This isn't just theory, it's practical. For example, a factory might use these principles to decide whether repairing old machinery or buying new equipment delivers better long-term value. Every choice is a calculated trade-off. Now, where does process economics apply? Let's break it down into three phases. First, process design. Before breaking ground, engineers model costs. They weigh capital expenditures, CAPEX, like buying reactors or conveyor belts, against operating costs, OPEX, such as energy bills or worker wages. Second, operations. Once the plant is running, economics drives daily decisions. Should we ramp up a production to meet a surge in orders? Or pause for maintenance to avoid costly breakdowns later? Third, decision-making. Strategic choices like automating a process or switching suppliers rely on economic analysis. Take a chemical plant choosing between two catalysts. Catalyst A is cheaper but slower, while Catalyst B costs more but boosts output by 20%. Process economics helps quantify which option maximizes profit over 5 years. In short, this discipline is the backbone of efficiency at every stage. Manufacturing doesn't happen in a bubble. It's deeply tied to external economic forces, i.e., the world out there. Let's explore three key drivers of process economies. Number one, the cost of raw material. When steel prices spike up, automakers might redesign car parts to use less metal. This isn't just engineering, it's economics. Number two, sustainability pressures. A cement plant might invest in renewable energy, not just to go green, but to avoid future carbon taxes. What seems costly today could save millions tomorrow. Number three, market demands. Seasonal shifts, like holiday toy rushes, force factories to scale production up or down. Ignoring these trends risks overstocking or missed sales. So, what are the main takeaway here? Adapt or lose competitiveness. Companies that fail to align processes with economic realities get left behind. So, how do industries stay ahead? Here are 4 proven strategies. Process optimization. Use data analytics or AI to fine-tune variables like temperature or machine speed. For example, a beverage plant uses AI to predict demand, ensuring they produce just enough to meet orders without wasting ingredients. Waste reduction. Turn byproducts into revenue. A paper mill might sell waste bark as garden mulch, transforming a cost into profit. Technology investments. Automation cuts labor costs while predictive maintenance sensors prevent unplanned downtime. Supply chain agility. Partner with local suppliers to reduce shipping delays or diversify sources to hedge against geopolitical risks. These strategies aren't optional, they're survival tools in today's fast-paced markets. South process economics isn't just about cutting costs, it's about long-term resilience. Take sustainability. A company might pay more for solar panels today to avoid regulatory fines or reputational damage tomorrow. This isn't charity, it's strategic risk management. Balancing ethics and profitability can be tricky, but it's achievable. For instance, a textile factory might invest in water recycling systems, reducing both environmental impact and long-term water costs. Remember, behind every process, there's a story of clever economics. Whether it's redesigning a product or adopting green tech, the goal is to thrive in an ever-changing world. To recap, process economics shapes how industries design, operate, and innovate. It's the lens through which every cost, risk, and opportunity is evaluated.